so that's the first answer is battery there. And the symbol for it, and number 2, this is come to short lines and a long line. Short line and a long line, short line and a long line. Usually you have a negative on one side and a positive on the other. And if you were to tear apart a battery, that's what you would actually see. Once again, is a bunch of plates that look like that. Number 3 says what device measures the voltage in the circuit. Well, once again, it's a voltmeter. It's usually a circle with a little V inside of it here. Number 4 says which device measures current. Well, current is measured in amps, so we're going to use an ammeter. Now, a lot of people say amp meter, but it's just ammeter. Number 5 says which instrument from question 3 and 4 hooked up to the circuit is in series. Well, it's always the ammeter, because just like if you wanted to figure out how much water went through a pipe, you would have to cut the pipe open to measure that. It's the same thing. You have to cut the wires open, so you have to put this in series. So if you notice the ammeter here, this little A, breaks the circuit on this side of the wire and breaks the circuit on this side of the wire, so you can see how much electrons are going through it. Number 6, it says which instrument is hooked up in parallel. That's going to be the voltmeter. So if you look over here at the diagram once before, if you notice with the voltmeter, let's see if I can scoot this over just a little bit. Okay. Whoops, that just made it completely off feature here. The voltmeter over here has a separate branch from the circuit. In other words, it makes a completely separate loop. And there's your voltmeter right there. So you don't have to cut any wires in order for that to go through. Just get all this back to the original screen there. Now, number 7, it says, how is the direction of the flow of the circuit indicated? Well, if you look at the arrows up here, it actually shows it's going, here's the current. It says I, there's a little arrow right there. And it always goes from positive to negative. And that's always sort of strange, because electrons actually flow from negative to positive. But you got to remember, that was sort of a misconception back in Franklin's and Edison's age, is that electrons flowed from positive to negative. They actually go the other way. But we never changed it, so we always say that current goes from positive to negative. It says, what is the resistance of the light bulb in the circuit? Well, if you look right there at the little resistor, this little squiggly line, you can't read it on your on the computer here. It says 15, so it's 15. This little horseshoe means ohms, which is the unit for resistance. It says, what is the potential difference of the electricity? Well, potential difference is the same thing as voltage. And if you look at the voltmeter, it says that the voltage here ends up being, I can't read it, so I think it's 30 volts. If you flip your paper over there a little bit. And then finally, what is the, it's 30 volts on the battery. That's what it says right here on the battery, it's 30 volts. And then finally, it says, what is the current? Well, if you look at the ammeter, this is reading 2 amps. So therefore, our current down here is 2 amps. So that is page 38. Go ahead and stop this, and we'll see you now at worksheet number 39.